So this is really a limiting reactant problem because you have an initial amount of two chemicals. So this is iron metal plus the Cl2, and it's going to turn into iron, and it says it's iron 2. So I'm going to need 2 chlorines because it's iron 2. So it's all balanced. And so we need to just make sure that we take both of these over to figure out how many moles of product are produced so we can figure out which one's limiting. So we're going to go with 1.42 grams of iron. And we'll go from grams of iron to moles of iron. Then we'll go from moles of iron to moles of FeCl2. And then from moles of FeCl2 until grams of FeCl2. And we're going to repeat the same thing, but we're going to do it with the other number. So 2.00 grams of Cl2, grams of Cl2 into moles of Cl2, moles of Cl2 into moles of FeCl2, and then moles of FeCl2 into grams of FeCl2. Then we just plug all of our numbers in. So 170.91, this is 1 to 1, and then that's 1 to, okay, so the molar mass, I've got to calculate that. Oh, it just wants to go to moles, so I went a little far here. I didn't actually need this much because it only was asking about the moles. So sometimes it happens when you're doing these, you kind of get a little ahead of yourself. It was just asking about moles. So that's 1 to 1, and then this is 55.85 in 1 mole. So now I can use my calculator, and I can do 1.42 and then divided by 55.85, and that gives me 0.0254 moles of FeCl2. And the other one is 2, did not mean to open up my usual manual. There we go. 2 divided by 70.91. That's a 7 there, if you can't tell. And so that number gives me 0.0282. And if you remember from the last chapter, the way you tell something is limiting is it's the thing that makes the smaller amount, not the big amount. That's our limiting. So this top reaction's the real reaction that we want to have going on. Oops. All right, so then if this is the enthalpy change for 1 mole, how much energy is produced in part A? So what this is meaning is negative 338 kilojoules is how much energy is released for 1 mole. So it's like a conversion right there. So 0.0254 moles of FeCl2. And there's 1 of those. So in 1 mole of FeCl2, I have negative 338 kilojoules. Now, because it wants to know how much energy is produced, it's that thing where like we understand that it's supposed to be negative. We just want to know the absolute value of this term. Then I'm going to bring my calculator over. So I have my 0.0254 times 338. So that's going to give us 8 point, and we're doing 3 sig figs, 5, 8. Well, in this one, I might round it up to 8.59 kilojoules. There you go. Oops.